Okay, so this is problem 9.3.47, and they ask us to solve the absolute value of 2x minus 1 over 9 equal to 7. Okay, and in this problem we have an absolute value equality. So the definition says that if the absolute value is isolated on one side and then you have a positive constant on the other side, then the way that we're going to solve this is we're actually going to drop the absolute value sign, and we're going to set the inside equal to the positive of the number on the right, and then also equal to the negative. So we have 2x minus 1 over 9 equal to positive 7, or it could also be equal to negative 7. The reason for that is the absolute value sign will make something positive. So if the inside was equal to a negative 7, whatever x we could put in here that would give us a negative 7, after we apply the absolute value sign to it, would give us a positive 7. So there's actually going to be two solutions to this. There's going to be whatever x gives us a positive 7 on the inside, and whenever x gives us a negative 7 on the inside, because when we take the absolute value of both of those, we'll get a positive 7. Okay. So what we want to do now is go through and solve both of these. We want to multiply both sides by 9, and that's to clear the fraction. So we have 2x minus 1 equals 7 times 9 here is 63. And then I want to add 1. So I have 2x is equal to 64. And then divide by 2, so x is 32. So that's one solution. Okay. Over here, same thing. Let's clear the fraction by multiplying both sides by 9. So 9's will cancel. We have 2x minus 1 equaling a negative 63. And then we're going to add 1. So we have 2x equaling a negative 62. And then if we divide by 2, x is equal to a negative 31. Okay. So these would be your answers here, negative 31 and positive 32. Okay. Alright, and let's also do this problem on the same video. So this is problem 9.3.67, and they ask us to solve the absolute value of 2x minus 3 over 6 equal to the absolute value of 4 minus 5x over 8. Okay, so it turns out that this is, actually the same thing as the last problem. It's just that instead of a constant on this right-hand side, we actually have another absolute value that has an expression in it. We're going to go ahead and treat this right-hand side as if it's a constant. So we're going to apply the definition here, and we're going to say 2x minus 3 over 6. We're going to set it equal to the positive of the right-hand side. But then we also need to set it equal to the negative of the right-hand side. So I'm going to take the negative of the numerator, because that would be the same as taking the negative of the whole thing. And notice that I've put the negative here on the outside of parentheses because it's a binomial term in the numerator. I need to actually distribute the negative there. Okay, so I'm actually doing the same thing in this problem that I did on the previous problem. I'm just treating this as the constant term. So here's the positive of the constant, here's the negative of the constant, and I need to distribute the negative. Okay. Alright, so now we want to solve both of these, and so over here I'm going to go ahead and multiply both sides by 24 because that is the common denominator there. So 6 goes into 6 once and into 24 4 times. So we're left with 4 times 2x minus 3. And on this side 8 goes into 8 once and into 24 3 times. So we have 3 times 4 minus 5x. Okay. So let's go ahead and solve here. Distribute the 4. We have 8x minus 12. And distribute the 3. This is 12 minus 15x. We want to get our x's together because that's what we're solving for. So I'm going to go ahead and add the 15x to both sides. So we have 23x minus 12 equal to 12. And now we want to isolate our x terms. Let's take this 12 and move it over. We're going to have to do that by addition. So we have 23x is equal to 24. And then last step here, divide by 23. So x equals 24 over 23 is one of our solutions. Okay. Okay. All right, this one over here, what we're going to want to do is first of all take the negative and distribute. So we have 2x minus 3 over 6 equal to a negative 4 plus 5x over 8. And I'm going to run out of room, so I think I'll just go to a separate piece of paper anyways. So we're looking at 2x minus 3 over 6, and we have the negative 4 plus 5x over 8. Okay, so this is, very similar to what we just solved because the common denominator is the same. These signs up here are different, so that's how it's going to be different. But let's go ahead and multiply both sides again by 24. So here, 6 goes into 6 once, into 24 4 times. So we have 4 times our 2x minus 3. And then we have 8 going into 8 once, into 24 3 times. And we're going to have to distribute that 3 through the whole parenthesis there. Okay, so we're going to show that with parentheses. Let's take the 4 and distribute. Again, we have 8x minus 12, and over here, now we have a negative 12 plus 15x. Okay, and if we want to get our x's together, so let's subtract 15x from both sides. So we have a negative 7x minus 12 equal to a negative 12. And then we want to isolate the x, so let's add 12 to both sides. Turns out in this particular example, negative 12 plus 12 is going to give us 0. So we have a negative 7x equals 0, and then if I divide by negative 7 here, 0 divided by a number is just going to be 0. So x equals 0 would be our other solution. So you have two solutions. This is from this one, and then the one that we found previously was x equals 24 over 23. So that's your second solution. Okay.